Your fingerprints, Unit 14, Lesson 1. Look closely at the tips of your fingers and thumbs. See those funny little lines and patterns? They're your fingerprints. Similar patterns appear on the palms of your hands, the soles of your feet, and your toes. If you look through a microscope at these lines and patterns, you'll see they resemble rows of plowed farmland or valleys and peaks of mountains. Though our planet has 5.7 billion people, no two, not even identical twins, have the same patterns. Those little lines that make up your fingerprints are called ridges, and these ridges form three basic fingerprint patterns: the arch, the loop, and the whorl. The arch looks like a small hill, the loop like a bobby pin, and the whorl like a spiral. These fingerprints may not appear to serve any purpose, but they're really quite useful. Beneath the skin of your fingertips are sweat glands, and these glands secrete oils that flow through the small pores on the ridges of your fingers. The ridges and the oils provide friction when you pick up a slick object like a wet drinking glass. Without the friction, the glass would slip from your hand. Your fingerprints remain the same throughout your entire life unless surgery, disease, or an accident damages them. Therefore, fingerprints are valuable for identifying people. Should criminals break into a house or steal a person's property, they may leave fingerprints behind on the objects they touched. These are called latent fingerprints. Latent means hidden. They normally cannot be seen with the unaided eye. The police use colored powder to highlight and develop latent fingerprints. They dip a brush made of fiberglass or very fine camel's hair into the powder and lightly dust any areas they believe the criminal touched. If fingerprints are present, the powder will stick to the sweat and oils the criminal's fingers left behind. The latent fingerprints are then photographed or are lifted off the surface with a piece of clear tape and placed on thin cardboard. Also, lasers can be used to find latent fingerprints. The bright lights cause the sweat and oils left behind to give off a yellow or a green glow that can be photographed. Once collected, the latent fingerprints can be compared with inked fingerprints kept on file at a police department's crime laboratory. Inked fingerprints are taken with a special ink that is applied to fingers. The fingers are pressed onto a white paper card, producing a clear copy of the fingerprints, ridges, and patterns. When comparing the latent fingerprints to inked fingerprints, experts look for certain ridge characteristics that match in both sets. By comparing the two prints, investigators can make a positive identification. Computers make sorting through fingerprint files much easier, but only the human eye can make the final positive connection. Before fingerprints were used to identify people, a man named Alphonse Bertillon created a system of identification that relied on measurements of certain body parts, such as height, length, and width of the head, length and width of the right ear, length of the left forearm, etc. But this method of identification was inaccurate. For one thing, any growth whatsoever made the Bertillon system irrelevant. Therefore, only mature adults could be measured. Accuracy of measurement was of utmost importance, but different police officers could measure the same individual and come up with minute differences in their results. The final downfall of the Bertillon method came in 1903. Two men in Leavenworth Prison in Kansas had the same name, William West. Their measurements were almost identical and their photographs resembled each other. But when both men were fingerprinted, the obvious difference in their prints proved that this was a far superior means of personal identification. Although the Chinese had used fingerprints for thousands of years to sign important documents, exact scientific research on fingerprinting didn't begin until the 1880s, and it was still very new when the West case destroyed confidence in Bertillon. In 1892, a British scientist named Francis Galton published a mathematical formula that showed no two people would have the same fingerprints. Galton divided the area of a fingerprint into 35 very small sections, each of which was still large enough to show considerable distinction. He then calculated the odds against any two fingerprints matching in a general pattern, in the number of ridges and in each of the 35 sections. He came up with a figure of at least 140 trillion to 1 against a coincidental match. This was enough enough to convince scientists and legal experts that fingerprints are positive proof of identity. In the 1890s, Sir Edmund R. Henry, also from Great Britain, used Galton's data and research to develop a classification system for recording, filing, and sorting inked fingerprints. The Henry system is used today in many countries throughout the English-speaking world. If you want to see what your fingerprints look like, put a small amount of watercolor paint on your fingertips and touch a piece of white paper. The paint will transfer your fingerprint patterns to the paper. Then use a magnifying glass to see the ridge detail and patterns more clearly. Remember, you and I are unique in the world. Our fingerprints prove this beyond a shadow of a doubt.